Welcome back. In this video, we will continue our studies of implicitly defined functions. We're going to look at how the two quantities in an implicitly defined function vary together. We'll also ask some questions about how an equation involving two variables can implicitly describe one or more functions, and are there relationships that cannot be represented by an algebraic formula. Also, we'll look at the ratio of the rates of change in the two variables, and can they predict behavior in implicit functions. In example 6, we're given the equation x equals y plus 2 raised to the y, and this cannot be solved explicitly for y in terms of x. In this one, we're asked to create a table of values considering two equations for x in terms of y. Then we're going to use those two results and then find the sum. So we're asked to create a set of ordered pairs and then graph. So in our table, they're giving us y equals -3. And the first thing we're asked for is to find 2 to the y. So if y is -3, we have 2 raised to the -3, which is the same as 1 over 2 cubed, or 1/8. So rewriting what I have here on the left, 2 to the -3 becomes 1/8. And then now we have x equals y plus 2y. Well, remember, y is -3 plus 1/8. So x is equal to -2 and 7/8. So our ordered pair here is -2 and 7/8, comma, -3, our x and our y. And we'll repeat that process. So when y is -2, we have 2 to the -2, which is 1 over 2 squared, which is 1/4. So we get 1/4, and then we have -2 plus 1/4, which is -1 and 3/4. So our x now is -1 and 3/4, or -1.75, and our y is -2. And we'll complete the table following that process. So I've taken the liberty to complete the table for you. And we have our 2y values, or 2 raised to the y values, which make up our x values. And then our ordered pairs of x, and then our original y. So here are our ordered pairs, and now we'll go ahead and plot our ordered pairs x, y. We're going to plot these guys, x, y, on our Cartesian plane. So I've plotted my points beginning at the top ordered pair, that's on the lower left here, and they just follow along as we move from left to right. So our graph is going to look something like that. And that graph does represent a function, because for every x, we only have one y value. It does pass the vertical line test. In example 7, we're given the relation x squared plus y squared equals 25, a circle centered at the origin with a radius of 5. And it is shown here at the right. It says use the points to find the ratios of the rates of change of y with respect to x over the given intervals. So when we're asked for rates of change of y with respect to x, this is what we know as our slope. We're going to find the change in y over the change in x between x of 3 and x of 4 in quadrant 1. So what we're going to have to do here is we're going to do f of 4 minus f of 3 all over 4 minus 3. That slope, it's what we've done multiple times this year, and you'll probably see something like this on the AP test too, where you're asked to calculate a rate of change. So when we put 4 in for x, we get a y value of 3, and when we put 3 in for x, we get a y value of 4. So that is just going to be 3 minus 4 over 1. So we get a slope of negative 1 over 1. So the slope between those 2 points, if I were to connect those to the line, the slope of that line would be negative 1. In B, we're asked to do the same thing, but between x values, x of negative 3 and x of negative 4 in quadrant 2. So I'm going to use these up here in quadrant 2. So f of negative 4 has a y value of 3, and f of negative 3 has a y value of 4, and all over negative 4 plus 3, which is 1. And here we have negative 1 all over negative 1. So we have a slope of 1 between those 2 points. So that was a slope of 1. Repeating the process for C, f of negative 4 minus f of negative 3. But in quadrant 3, our y values then are negative 3 minus a minus 4 all over negative 4 plus 3. And here we get a slope of negative 1 between those 2 points. And then we'll wrap up with doing the fourth quadrant in D here. We're going to get a slope of 1. You can pretty much be assured of that. That slope is going to be 1. And we'll move on to the next sample. And sure enough, in the fourth quadrant, our y values are negative 3 minus a minus 4. So negative 3 plus 4, which is 1 over 1. And sure enough, we have our slope of 1. In example 8, we're given the equation y cubed minus x equals 2. We want to find the rate of change of x with respect to y on the interval x's between negative 2.001 and negative 2.0. We're first asked to solve for y in terms of x explicitly. So our goal here is to get y equals. So I'm going to add x to both sides. So I get y cubed equals x plus 2. And we'll take the cube root of both sides. So we get y equals the cube root of x plus 2. Then it says use a calculator to find the rate of change on the interval that we're asking for, negative 2.001 to negative 2.0, and then show your work. But now remember, they're asking for the change in x over the change in y. So we flip our slope equation here, which is interesting. So we get negative 2.001 plus 2, which is negative 0.001. Now we have to go in our table of values and find out what f of negative 2.001 is in this function and f of negative 2.0. So at my graphing calculator, I go ahead and put in the cube root of 2 plus x, and then I'm going to go to my table set menu. So second table set, and I'm going to start my table at negative 2. Mine shows here negative 2.005, but I could just start it at negative 2.0. And I'm going to do my change of table because I'm going just to negative 2.001. So I'm going to count by 0.001s. So I've got that. And then I'm going to go to table, second table, and it gives me a table of values. Now I'm going to have to cursor up a little bit so I have some more values. And now I have my negative f of negative 2.001 is negative 0.1, and f of negative 2 is 0. So I transfer the information into my equation, negative 0.001 minus 0.1. The negatives become positive, and I get 0.01, which is almost 0. Let's take a look at this graph and see what it looks like on our graphing calculator. So I'm just going to graph this in the standard window. I think my just go zoom standard, and we get our graph. Now we're evaluating our function here at -2, and you can see we've got it seems like it almost goes vertical here at -2. So we could zoom in on that, or we could see what's going on there. But we know that our slope here, actually it wasn't our slope, it was our change in x over change in y was almost 0. So let's think about that for just a moment. So we saw that our slope here, or actually it's not our slope, right? It's our change in x over change in y is almost 0. Well, a 0 slope for us is normally like this. So now, since we're flipping our x's and y's and we're almost 0, it totally makes sense that our graph is almost perfectly vertical there, okay? The reciprocal of 0 is undefined. So 0 slope would be a horizontal line. But now, since we're flipping our x's and y's, it totally makes sense that this is vertical at this point of -2. So what's the behavior of the function on this interval? Well, I would say the graph is almost vertical. And that is consistent with a reciprocal slope of 0. In example 9, we're given x squared plus y cubed equals 8. Find the rate of change of y with respect to x on the interval. So that's going to be a regular slope. I've got change in y over change in x. And we want to find that between -1/10 and +1/10. So we're surrounding 0 here. We're kind of straddling our 0 value for x. And so we'll see what's going on there. And then let's go ahead and solve for y in terms of x explicitly. So I'm going to subtract x squared from both sides. So I get y cubed equals 8 minus x squared. I'm going to go ahead and take my cube root of both sides, and I get y equals the cube root of 8 minus x squared. We'll put that in our graphing calculator and take what that might look like, and we'll find out what our slope is between -1/10 and 1/10. So I put my function into my graphing calculator. I've got the cube root of 8 minus x squared. If you don't remember how to get the cube root, you can go into the math menu, and then in option 4, we get cube root there. And 8 minus x squared. And then we'll go into our table. We'll set our table. We're going to start at -0.1 actually in this guy. And then we're going to count by 0.1s. And we'll go to our table. And it gives us 1.999 for f of -0.1, our y value, and 1.99 for 0.1. And we'll see here that the difference between those two is 0. So our numerator is going to shake out to be 0. So we get 0 over -0.2, which is just 0. So our slope, it appears, at the origin, or as we approach the origin, is going to be 0. So it's going to be a flat line there when x is around 0. Let's take a look at our graph and see what's happening. So I go back to my calculator. I'm going to reset my window for this guy a little bit. I'm going to set my x's between -5 and 5 because we really want to see what's happening for x's around the origin 0. And I know what's going to happen, so I'm going to set my y's at -5 to 5 as opposed to just doing this in the standard window, and we graph, and sure enough, when we grab these x's around the origin, it looks like our slope here is 0. So what is the behavior of the function on this interval? Remember, we're looking at really close to the origin, and we saw a slope of 0. So the graph is approaching horizontal behavior as x approaches 0, and because the rate of change approaches 0. And in summary, here in example 10, we can see that for ordered pairs that are close together on the graph of an implicitly defined function, if the ratio of the change of the two variables is positive, then the two variables are either increasing or decreasing simultaneously. That should make sense. If you have a positive slope, they're either both going positive, positive, or negative, negative. So something positive over a positive or negative over a negative. Where in for ordered pairs that are close together on the graph of an implicitly defined function, if the ratio of the change in the two variables is negative, then as one variable increases, the other decreases. So that's that positive over negative or negative over a positive. And as we saw in example 8, when the vertical rate of changes of change in x over y is 0, so we don't have a horizontal slope because it's x over y, we will have a vertical interval because we're flipping our x's and y's. So 0, it's not slope, so it's the reciprocal of slope. So that is going to be 0. Whereas when the rate of change in y over x is 0, well, that's our normal slope, and that will be a horizontal line, as we saw in example 9. And that finishes up our studies of implicitly defined functions, and we'll get some more practice with this when we see you in class.